Example 4.1 from the prior book has Starbucks data and involves transforming data. Although Starbucks Corporation began in 1971, it's seen tremendous growth in the number of stores since 1987. So the following table lists the years from 1987 to 2004 and the number of Starbucks locations. You can see them there. If we look at a graph of the data, we can see a definite curved relationship, or definitely a nonlinear relationship. So what we want to look at is see if we can transform this data and turn it into a linear relationship. Since growth can frequently be represented by an exponential model, we're going to see if the data can be transformed into a linear relationship by taking the log of the y variable, or in this case, the log of the number of stores. So I can input all of this data into my calculator if I want, into L1 and L2, and then I'm going to take the log of L1 to end up with a list of data like this. If I now graph the year and the log of the stores, I get a graph that looks like that, much closer to a linear relationship. At this point, you can either use linear regression on your calculator, do linreg of L1 and L3, or I can do regression on some computer software package like Minitab. If I use Minitab, I'll end up with, here's the Minitab output. So I can look at this output and see the y-intercept is this number right here. And this number, the coefficient of the year, is the slope. So I end up with this, really with hats over here, and we sort of claim those are about the same. To see the number of stores that would be in 2005, just entering 2005 into that equation. That answer is the log of the number of stores. So anti-logging both sides will give me the estimated number of stores is 19,458. Using my calculator, it would look like this. Negative 313 plus 0.158 times the year. When I hit enter, I get that, and then I will anti-log that answer to get approximately the hat, approximately 19,458 stores. Now the question is, how well do you think this equation here estimates the number of stores? Well, I can see from the Minitab output that r squared was 98.5. That's the coefficient of determination. That means 98.5% of the variation in the log of the number of Starbucks stores can be explained by the least squared regression line of the log of y on year. Since that r squared is so high, we feel pretty comfortable with the line, but I'd still like to look at the residual plot. Looking at the residual plot, I get this definite pattern. This suggests that another model may do even a better job of predicting the number of Starbucks stores since the number, rather than the one that we found here. Notice also that the values right before 2005 are all negative. So the residuals are negative. Consequently, we can expect that the prediction that we have here, this 19,000, may end up being a little bit higher than the real value. Finally, a note, even though your calculator may not let you do inverse transformations all the time, in other words, sometimes the years, those numbers are just too big, you can actually input coded years. For example, you could use years since 1980, or sometimes the years are just redefined as 0, 1, 2, 3, 4, 5, and you just have to make a note of that.